Ian, the first question from our website is, what considerations do you have to take in order to engineer the body of a car?
Well, in the initial phase of the project, we develop a specification for the technical requirements of the car. As well as legal requirements like crashworthiness, we consider the temperature, humidity, vibration levels of the car in use, which are often much more severe than for standard road cars. Then there are our own targets for weight, stiffness, visibility, ease of access, the kind of attributes that make a Mclaren what it is. From that starting point, we consider the possible solutions for each system from a technical standpoint, and in each case we'll carry out some analysis and maybe some initial prototype testing to prove that the system will meet the targets we've set for it and optimise the design according to the results. For each component we need to take into account the material and manufacturing method to ensure that the part can be made to a high quality level within the budget that we've set. And we also need to make sure that the car can be assembled easily to ensure that it will give reliable service with all the systems operating as we'd intended. When all of those aspects have been considered, we can start the detailed design of each component.
So it sounds a very complex process. So exactly what are the materials that Mclaren uses for its body and its structure?
Well, our approach is to start from a sound understanding of the requirements of each part in terms of the function, forces, durability, cosmetic finish and so on. We use analysis methods and our experience to select materials and processes which will optimise the performance for a given weight. For the underlying structure, carbon composite materials give us huge benefits in maximising stiffness and keeping weight to a minimum. The processes we use allow us to tune the layup, that is the way that the fibres are stacked and orientated in the moulding, to take account of the loads in local areas of the car. That's a very efficient way for us to meet our structural targets. For the external panels, we use a number of techniques based on composite materials, but there's no reason why we wouldn't use sheet metal stampings if that gives us the best finish at the lowest weight. It's a question of using the right material for the right application. It's about everything for a reason.
What does that mean in terms of the styling requirements and how they're integrated with the engineering of the vehicle body?
Styling the car is a specialised skill, and it's not typical to find a stylist who has a detailed understanding of the packaging requirements and manufacturing methods for the parts that make up the car. We work alongside the stylist throughout the creative phase to ensure that the car is designed around a technical package which allows us to meet the functional and performance targets within the final style. Take for example a headlight. The stylist will want to create a unique shape for the front of the car and may want us to look at the feasibility of something very unusual. It's our job to look at the available technologies, in this case say xenon lamps, LEDs and so on, and advise on what can and can't be done with the physical form of the lamp. The goal is to end up with a style which looks amazing but maintains the packaging requirements, and in this case you'd be thinking about legal requirements, heat management and nighttime performance above all else.
One question we had from the website is, why does Mclaren have dihedral doors?
One of our objectives is to offer cars with class-leading levels of performance but with real everyday usability as well. A close coupled package of the car, meaning the occupants are very close together, means it will always be more difficult to get into and out of than say a typical saloon car. The dihedral door allows us to give the customer a much better and a more comfortable way to get in and out than they could expect with conventional doors. It does present us with some very interesting engineering challenges to solve. If you think about water management, for example, we have to consider what happens to water not just when the door's closed, but also when it's open. So the rules of car design are turned almost literally on their head. As well as being practical, of course, I think the dihedral door also looks pretty cool.
And finally, what's it like working as an engineer at Mclaren compared to other automotive companies?
Well, I came from a volume car background when I joined Mclaren in January 2000, and it was like stepping into a different world. It's a very small engineering team by comparison, but the range and the depth of the activities involved is just as large as for a low volume car as it is for a standard production model. In larger automotive companies there's a strong tendency to compartmentalise so that large departments of specialists grow with a fairly narrow range of responsibilities. That gives technical strength but can lead to organisational inertia, and we need to be much more nimble and flexible than that. So the typical engineer's brief here is a very wide one and covers the development of a number of systems right from concept through to series production. We have the benefit of being able to consult with our colleagues at Daimler Chrysler when we need in-depth experience on a topic that's outside our experience. At Mclaren we have the best of both worlds, a small, lean organisation that can react very quickly, but able to access the resources of a large company with over 100 years of car development experience. Given the special challenges of high-performance cars in terms of heat, load, structural efficiency, the opportunity is there to get involved in a wide range of technical areas. So I found that I can influence both the strategy and the implementation of our technical and product plans, even as the company grows and moves on to ever more ambitious projects.